I'm Chris Malec, and let's see. So I've been working as a data scientist for FinRA for the last couple years, and actually my relationship with them has ended about 2 weeks ago. So, and I haven't actually, the offer letter for the new place isn't actually in my hand yet. So I'm just going to say that I contract with tech systems. But yeah, so basically I'm working as a data scientist. Apparently we did such a good job at our deep learning initiative to apply deep learning to the stock market, looking for manipulation in the stock markets, that they didn't need us anymore. So, yeah. Well, yeah, it was a big project. It wound down. They didn't need all of us. I drew one of the short straws. So it goes. But yeah, so today I'm going to talk about Pandas, which is a great library for data analysis. Kind of at FinRA, most of the databases are gigantic, like billions of financial transactions per day with hundreds of columns, SQL databases. And so we don't really use Pandas to directly look at those. Pandas usually comes in a few steps in. As I'll mention explicitly a little later, but at about 5 million rows, you should definitely start using something like Spark or one of the cluster-friendly SQLs. But yeah, Pandas is centered around this thing called a data frame. You'll find data frames in a few different packages like Spark or R. And it supports indexing, merging, and transforming data. And the nice thing about Pandas is it plays nice with these other common libraries in the Python world. So matplotlib and plotly, I'll show you in scikit-learn is one of the big machine learning packages in Python, and NumPy is kind of the math Python. But yeah, so basically the structure of this talk is I'm going to go, Pandas is too much. You can do everything in about 3 different ways. So it can't be everything to everybody. But what I'm going to try to do here is I'm going to go through some stuff where we look at just really tiny, cheesy little data frames. So like 4 rows. And just how do you do some basic things. I want to talk to you about kind of something that's a little more realistic, and just because I think it's interesting, something that might relate to market manipulation. And just in case you were wondering, don't do it. It requires a lot of capital. And yeah, you really, it takes money to make money, and that goes for manipulation. Also, obviously I can't say exactly what we do, but we'll find you. Okay. And then last, I want to look at something like just maybe data that's a little more realistic. We're not going to draw any big conclusions from it, but just to kind of see what data from the real world might differ in how you have to handle it. Okay, so 1, creating data frames, because I told you these things are data frames, so you got to make them, right? This is the very first thing you got to do. You got to import Pandas. Officially, you do it as PD. You can do it as anything you like, but you'll confuse people if you use a different abbreviation. So let's see. So I made 2 lists here, A, B, C, D, and 1, 2, 3, 4. And I just say make a dictionary where the key is the column name and the list is the data in the column. And you see, I just make this little, spreadsheet, little mini spreadsheet here, and that's the data frame. Let's see. And there's lots and lots of ways to make data frames, so I'm not going to cover them all, but these are a few ways. If you like NumPy, which again is how you do matrix math in Python, here I just made a list of 8, turned it into a 4x2 array, and you can just say that that's the data, give it some column names, and there again you have your data frame. Obviously, in that case, NumPy arrays you usually just use them for numbers. So you'd probably come across that if your application is more machine learning, and you want to basically take your giant data frame and just strip it of all connection to the real world and put it into a machine learning model. And then finally, this actually, I end up using this a lot when I actually pull data from real sources, because this plays well with kind of JSON-y type records. So yeah, just if you make a list of tuples, each of those tuples is a row. And for those of you new to Python, the tuple is just what you make kind of sets of numbers like A1, B2, C3. They can be any length. But yeah, and then you get a data frame again. And then finally, this is just an example data frame that I'll be using for the next few things. And it's the same as the last one, except I added an index to it. So you can just see first, second, third, fourth is my index. And I can refer to rows by that index. And a lot of times, I don't always use all the index functionality, just because the important thing to remember about indexes is that you can't treat them like a column. They're the index. What I'm going to show you that you can do to the letters and numbers columns, you can't necessarily do to the index. It's kind of like in an Excel spreadsheet, the left-hand column with all the numbers on it, you can't do math on that. Okay, so selecting columns. This is usually a pretty important thing you want to do. And it's driven by this loc command. So you can select columns. And if you make the column, and the colon means that I select all the rows. And then this list of columns is just which columns I want to keep. Since I made it a list, even though it's only one long, it returns a data frame. Now, if I don't put it inside a list, it returns what they call a series. It called it an object, but I think that has to do with the IPython display. But yeah, so this returns what's called a series object. A series is basically the one-dimensional array in the Pandas world. And you can, if you want to make some kind of complicated list comprehension to select things by first letter or, anything else you can think of, you got some regex that's going to get your column names for you that you can put it right there and it'll work.
Chris, is it normal for pandas to overload the slicing syntax?
Yeah.
Okay, that's
Yeah.
very atypical Python for the layperson. Probably is like, what's going on with that?
Yeah, no, that's the best and worst thing about pandas. If you kind of think, maybe this will work, it probably will, until it doesn't. There's a lot of different ways to do everything.
You can use the colon notation too for the columns.
Yeah, I think that's kind of taken from R, as far as I can tell. Because that's definitely not just base Python. That's a Pandas thing. In fact, this whole square bracket thing is definitely that's where kind of it mapped from R, because having a method that has everything related to it in square brackets is just not very Python-y. I don't see it in any other package.
The thing that's throwing me is the comma after the colon.
Yeah.
It's like,
Oh.
is that
The first one
Oh.
is, that first one is a range of index, the second is what.
Yeah, sorry.
Column.
So see, rows, columns.
okay.
So the colon means all the rows, and then whatever I put here selects columns.
Oh, I see.
And maybe that'll be a little clearer if we now switch to the other thing.
Derailed.
No, it's important. Like, it's so hard to remember, like, which things that you do every day are jargony. So, but yeah, so this is, we're doing the same thing, only it's for rows, right? So we have this index, and I just want the first and third row. So I can put that list there, and then I've selected my rows, comma, and then colon selects all the columns. I could not do the not do the colon and select only one of the columns as well. You can do select either at the same time.
So if you had A, B, C, D as column names, for that second half, you could do A colon B, and one only for A colon C. You'll be all columns.
Oh, yeah, so I think, let me go a couple further, and I think we'll see the type of selection you're thinking of, or maybe I'm wrong.
Yeah, because that colon's really misleading the first time you see it.
Yeah.
That does what the first one does, except instead of index, it's column.
Yeah, no, I see what you mean. And yeah, it is kind of confusing because, again, NumPy also uses the the colon syntax to kind of mean an extension of different columns, but not quite the same way. So yeah, it is what it is. It's weird, but it's how it works. So I think this is what you were saying. Tell me if I'm wrong. So
No, the second half of it's comma. So like, think if you replace that comma colon with numbers, colon numbers, like you will.
Oh.
So like if you had call A, call B, call C, call D, you did call A, colon, call C, you get everything between column A and column C.
So that's more like a slice.
Yeah.
It's like a traditional slice syntax. That's what fits in my brain. Is like I see colon and I think slice in Python, and here it's like colon.
Yeah, and actually,
You can manually create a slice object instead of the colon, and it works the same. It's just a
yeah, and I know some of the slicing has been deprecated.
Okay.
That kind of looks like I think the slicing you're used to. But yeah.
You can even do things like columns in alphabetical order.
Mm-hmm.
I think you can even put B colon A, and then it'll actually wrap around, kind of like you normally do with like a minus. So it's
Yeah, I think if A and B were the index, I think it would do that. So you cannot
I'm talking about the second part where you're giving it the columns.
Okay, where
So
you're
you give a
giving it the
range of
columns.
column names.
Okay.
Like you can give a range of index.
Yeah, okay.
Is a data frame always? Should we always be thinking of it as a two-dimensional thing?
Yeah, it's always, data frames are always 2D.
Okay, cool.
Yeah, no, arrays, it's not like an array or an ND array or anything else that you can make in infinite dimensions. It's rows, columns.
Cool.
Those could hold data.
Yeah. And so it just, I put this here because it's important to note that you can't really just directly reference the columns to kind of select rows. You got to do this kind of like the column from this specific data frame. If it's less than 2, I want those rows. So you see this has selected only the first 2 rows because the numbers column is less than or equal to 2.
So is that's referencing the values in the columns?
Yes, and you gotta, so you really need to, you can't just like write numbers there, because then it'll think you're talking about some variable called numbers.
Yeah.
But, and I just put this here because you can, in fact, just do the data frame dot the column and get a series, like a 1D object, with the contents of that column. Okay, so then hopefully we're kind of down on the weird row column thing. But the important thing to remember is the first one is row, the second one is column. After rows comes columns. Before columns comes rows. No, they had me teach one of the bioinformatics classes here once. I spent a lot of time just drilling, like, no, seriously, rows, columns, rows, columns, rows, columns, rows, columns.
That's why.
Yep. And that's exactly the same deal. Okay, so now that we have a data frame and we can pick the stuff that we don't want to see out, now we want to do stuff, because presumably if I could just create a data frame and pass it along, I would not be worth the money they pay data scientists. So yeah, so I just made a couple of dumb functions here. We're going to multiply all the numbers by 2, and we're going to make all of the letters uppercase. And so here, I apply these 2 functions, and you can see you can use this apply method of the data frame with a dictionary to apply different functions to different columns. If you want to just apply the same function to all the columns, you can just pass that function to apply. Whereas in this case, I realized quickly that I had chosen a data frame where it was difficult to choose a good function that worked on both columns, so I just decided that I'd be fancy here. But, and you're going to see this applies to a lot of stuff. A lot of these methods, you can pass a dictionary to specify different behavior on different columns. Okay, now combining tables. So this is, of course, very important because ideally your database is just one big flat table that you pull data from, and that like never happens. So you have to combine tables. And even if you get lucky and most of your data can be taken from one big flat table, you have to do some operation on it and then join it back to the original table, lest you have to group by about 370 keys. So that's, you're going to have to combine tables, and you're going to have to do it a lot. So Pandas way is usually this merge function. I see this rename part got cut off a little, but that's okay. It's kind of the least important thing happening here. So you see, I create this second data frame where I just multiply all the numbers by 2, but I keep the letters exactly the same. Unfortunately, once you start this dictionary thing, if you don't give every column a function, it just won't make them. So if I just passed it numbers times 2 in the dictionary, I would only get that 2x numbers column you see on the right. So that's just a second table, so I can merge them. Okay, and then I take one data frame, my original data frame, that XDF, and then merge it with that XDF2, and then it's just like it's pretty much just like a SQL join, and it's on letters. So you can see here, just the left data frame has ABCD. The right data frame has ABCD, And so the new data frame it makes matches the A row to the A row, the B row to the B row, the C row to the C row. And it's got the numbers column from the left data frame and the 2x numbers from the right data frame. So this is how you're gonna, this is kind of your bread and butter way to combine data frames.
What's the index number, or the index names?
Yeah, they went away because of the particular, so they turned into the default 0, 1, 2, 3. And so actually there's a different way you can do it if you want to preserve your index names.
What's the behavior if you have a mismatch? Like you try and match on letters and you have, you have the G or the other one.
Oh, yeah, so the default behavior, and I will address this, I don't think exactly what you're saying though. So the default behavior is what's called an inner join. So you'll only get rows where there's a match.
Okay.
So if there are no matching rows, you just get an empty data frame. And then if you have called something on that data frame, it'll be bad. You called a method on none. You're a bad person. Yeah, the Pandas error warnings are kind of brutal, but sometimes you need to hear it.
So if there's no match, it won't return like an empty data frame, it will actually return a none type?
I believe it returns a none type.
Okay.
Do not quote me on that though.
Fair.
YouTube for the future watching. Just I don't know if that's true. You should try it before you stake your career on it. I don't know how you would end up doing that, but check. So this join operation is pretty similar to merge, except the default behavior is to look at the index. So this is how you keep your index if you want to keep the index. So see XDF join to the XDF2. And so it's matching on the index. And since the index is exactly the same in both, it finds matches on all the rows. And you also notice that the letters column is the same in both data frames. So this is where this little suffix comes in. You can specify, I want any duplicated column on the left data frame to have an _L, and any duplicated column in the right data frame to have an _R. I'll show you what happens if you just duplicate the columns in a little bit. Let's see, and then you can, if you're feeling really lazy, you can actually specify different columns to merge on the right and left data frames if you just don't feel like renaming columns in one of the data frames, which honestly can kind of mess you up. So if these two columns had different names, I could choose the left data frame matches with a different column in the right data frame.
I think there's a how argument you can do in there, however.
Sorry?
There's a how argument we can tell it to do in there.
Oh, yeah. And I think I'm going to use that, I think, in the next one. Yeah, and so this is, the default's the inner join. And so here's a case where if I merge on the numbers column and the 2x numbers column, obviously only two of the rows have numbers in common in the data frame. So I only end up with two rows where the 2 matched a 2 on the right and the 4 on the left matched a 4 on the right. Okay, so this is, yeah, so this is where I'm doing a right join. No. This is what happens when your columns are duplicated. Okay, so this is what happens when your columns are duplicated. You get, sorry, I'm just skipping ahead to, Okay, I think I got off a little here. Okay, but this is what happens when things don't match, and you use the right So unfortunately, this was important, and I should have let this get cut off. But right here, it says how equals right. So this is a right join. So see, it's looking at the numbers. And so once again, there's only 2 rows that match. But these 2 rows that don't match in the right data frame get passed to the resulting data frame anyway. And so the rows that don't exist in the left data frame, those columns get a null value or an NaN. And so and this is the same behavior as a right join in SQL. And so you can do the same thing with a left join where everything gets matched on the left, but only the stuff on the right that actually matches ends up in the resulting data frame, and anything that doesn't match gets a null value filled in. So is that kind of clear how it works?
Is it a true Python NaN, or is it a none?
That is a NaN. That's
Okay.
a real NaN.
So like, subtle distinction there is that in Python, none can equal none,
Mm-hmm.
but in a NaN cannot equal a NaN. So
No,
that really matters too much from any context, but just so you're clear, you're like, it's intended that way so that if you did math on it by accident, that you're like, it'll blow up earlier, I think, if a NaN doesn't equal a NaN. So
Yeah.
if it was just to equal nuns, some stuff might slip through and you might do equality and you're like, oh crap.
And that's exactly the kind of stuff where when you're dealing with real data, like how you handle various null values is how you get. I've gotten into a lot of trouble that way. Like
Yeah.
I think one of the biggest screw ups I've made is related to null handling.
How do you test for NaN if NaN doesn't equal NaN?
There's an is and a function.
Oh, is there?
Yeah.
Yeah. Actually, I'll use it later.
All right.
I have a question too. Is the data, is there a type to it actually? Like, because I found out last time.
Oh, yeah.
It went to a float from an int, and I was like, I haven't seen anywhere where like, when we try to join.
Yeah, honestly, I'm not sure why it does that. But that is interesting. But they are typed.
They are.
I do not know why it did not preserve the type there.
It's backed by NumPy arrays.
Yeah.
And so, and I think NumPy arrays now support NANs in integer arrays.
Oh.
I think Pandas has been 1 year away from adding that for like 4 years now or something.
Okay, so that's since there's NaN values, that's why. That makes sense. Okay, so now again for the SQL folks, this is more like a union. For the NumPy folks, this is like concatenation. It's concatenation. And so, yeah, just again, I'm still calling it a left and right data frame, but now we're just mashing them together. So I just put the data frames in a list here. So just XDF and XDF2. And say join it along axis 0, which is rows, because rows comes first before columns. And I tell it to ignore the index, so it just creates a new default index. And yeah, that's concatenation. You can also do it the other way. So here I do the same thing, except I specify to concatenate along axis 1, which is columns. And so again, you see I have duplicated column names if I do it this way. In most of the stuff I do, I almost never want to concatenate this way, but there are definitely use cases. And I just wanted to quick show you what happens if you then try to select the duplicated column. You get them both. I did not even know what was going to happen.
If you concat that way, does it honor the index at all, or is it just a blind concatenation?
It does.
I was just wondering what the...
Yeah, it does. I think it does honor the index unless you tell it not to. And in that case, it will probably concatenate just whatever sort it's in at the time you call it. So yeah, that would be a good thing to double check. Again, almost everything I do, I don't want to concatenate that way. Okay, so there's two things most people do with pandas, and that's plot data and stick it in a machine learning model. Plotting data makes pictures, and it's a lot easier to do than making a machine learning model like in a talk. So I decided to plot some data. So there's two major nice things and ways to plot data in pandas, that I use most of the time. Matplotlib actually like if you import Matplotlib, you can just call methods, you can just call the plot method on your data frame and it'll make this Matplotlib off of your data frame. So this is like just super quick and dirty. I need a graph of my columns right now, and it's kind of nice.
This is in Jupyter Notebook, though, right?
Yeah.
Yeah. You do this from the Python REPL.
Yeah.
Give you what you want.
Yeah, and I occasionally figure out how to get the right standard out to actually pop up a ping or something. But yeah, Jupyter. This is kind of one of the reasons to use Jupyter Notebooks, And then what we usually use is Plotly, because it makes things interactive, which there's nothing super interesting with this graph you can zoom in on, but it means I can actually interact with that graph. And so, but again, you just take your Plotly type, and you can just put the data frame right here, and then all of the various attributes of the graph you're making, you just refer to the columns in your data frame as a string. And that's only for Plotly Express. I'll show you the more old school Plotly that where you need to actually kind of specify individual series, so a certain column of a data frame. But yeah. And summarizing tables, this is another very important thing you want to do. You can just call the describe method. It'll give you all these little statistics for your different columns, in this case just the numeric columns. You can do aggregations, so you could sum, so I've summed up all the numbers here, and I've taken the minimum letter here. And here I'm just making a big old data frame, big old compared to my 4 prior examples. And you can do group bys. So you can call group by on a data frame. I want to group by the letters. So everything that's in the A column that has a letter A gets grouped. And in this case, I ask it to sum everything up. So it adds 1 and 1 and 1 and 1 and gets 4. So hey, I'm still good. I'm still good at addition. And you can do multiple aggregations. So I can group by the letters again, and I'm going to aggregate the numbers column with the minimum, the maximum, the sum, and the count. And there you go. And this also brings up the fact that you can have these hierarchical column names, which are both super cool and super annoying. So this is what, if I actually get it to spit out the column names, this is what they look like. They're tuples. So numbers min, numbers max, numbers sum, numbers count. And in fact, if you put those tuples in the select command, you would get that column name. But if you just put min in the select command that we looked at earlier, you would get, there's no column named min, silly. And finally, this is kind of getting a little more niche, but melt and pivot are two of the more advanced data frame concepts. So basically, if you melt it, you say, I don't want all these columns. I want all these columns to just be like two columns where one column is the value and the other column is the type of value. And I'll show you a use for that towards the end. So see, min is 0, min is 1, min is 2, max is 0, max is 1, so that's melted. And then pivot is the reverse. It's saying like you have something like this, but you want them as separate columns. Okay, so real life. Let's, I'll try to make this fairly brief, but we want to look at real life. Null values are a lot more important. There's a lot of data types. Sometimes they, data in the wild may have never seen Python before. They might not know how to play with Python. They might not fall into one of its data types. And just getting like the file into a data frame, like that very first step where you create the data frame is sometimes half of what you're doing, and you feel like, good God, I haven't done anything useful for days. But like you're doing something useful. You're getting it into a data frame so you can do the stuff you got to do. And the size can easily get out of hand. And like I said, Pandas starts chugging at a few million rows, so that's about your limit. So what I want to show you today is some data from the IEX order book. Why IEX? And what is an order book? And what is market manipulation? And what is Reg NMS? That you might sleep through that one. If you have some lost time, that's where it is. And how can anyone hope to find manipulation? So IEX, I'm taking data from IEX basically because they're one of the smaller exchanges. They have this kind of reputation of being like the quote unquote good guys. They were founded by people who kind of kept getting screwed by high frequency traders. And so they wanted to make an exchange where high frequency traders didn't have quite the edge. And just they don't do a ton of volume, but they do actually make their order book available for free. I gotta pay some cash for NYSE and NASDAQ. What is an order book, since I say it's free? Well, every time you hit buy on your Charles Schwab account or sell on your Robinhood account, like an order is created. And the order goes to the stock exchange eventually. And it says, hey, someone wants to buy this stock, 100 shares of it, for $45. And if someone wants to sell 100 shares of that stock for $45, you do a trade. If everyone's like, no, I'm not parting for this for anything less than 45.10, you don't do a trade, and your order rests on the books. And then what is market manipulation? So there's many types of market manipulation, but this is a fairly straightforward scheme. And basically, if you look at the order book, you've got kind of some people putting in some buys, some sells, and then you got Mr. Manip here. And they're just like sell, 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 sell. And they keep going for lower and lower prices. You see there's someone who is willing to sell at 45.05. And so they keep undercutting Mr. 45.05. And then Mr. Albite eventually agrees to buy at, put in a sell order for 45.02. And Mr. Manip actually wanted to buy. They didn't want to sell at all.
I actually worked on that layering.
Yeah. So this is layering, spoofing.
It's only illegal because the order itself isn't illegal, but you never intended to honor it.
Yeah. It's the fact that it's you wanted to buy. That's what you meant to do. And you're creating all these signals that like, there's all these people, you're basically saying, people are wanting to sell this stock. I've heard people say. Now, the important thing to remember here is when you're actually looking at stock, exchange data, no one gets to see this rightmost column. So if someone starts putting in a bunch of sell orders, maybe it's just some person trying to trick you, or maybe it's a bunch of people who were on Twitter and are like, oh my God, the CEO just had a heart attack. Sell.
If you put 1,000 orders on one side of the market, then all of a sudden execute on the other, and at the same time cancel.
Yeah, and I'm going to show that graph. Yeah. And one of the many things that makes this possible is Reg NMS, meant to protect you and me. And this is just a regulation that all when various firms like Charles Schwab receive an order, they have to give you the best execution. So, for our purposes right here, that basically means if NYSE's got the stock for 45.05 and NASDAQ's got it for 45.04, you have to get it for 45.04. And this rule is meant, and this rule A is was meant to create this network of these stock exchanges. In practice, it's ended up creating a bunch of stock exchanges. So there's like 15 now or something, which is a lot more than there used to be.
Plus a bunch of ETFs and dark pools.
Oh yeah, man, I'm not even getting into dark pools today. But yeah, from the name dark pool, you can just say, this is cool. This is something that's legit, that I'm completely okay with. I've noticed that there's actually at least someone out there who called their ATS a light pool. So I think they're at least aware of the bad messaging that dark pool sends. But yeah, these are just like basically private exchanges that like exist within JP Morgan. And
some of them are for large institutions.
yeah. But yeah, they're not necessarily nefarious, but like people definitely use them for nefarious things. And hey, how can anyone find it? Well, because the regulators get to see a lot more information than the rest of us. So I made a slightly bigger, more realistic data frame, and which has orders and canceled orders. And here, someone actually traded. And, I just do a timestamp thing there. So this is what we'd actually look at. Does this look kind of familiar?
Then you're looking at a window around another action.
Yeah, but the big thing here is we've got that blue dot on the bottom is kind of one firm who's putting in a buy order, and that orange dot on top is a sell order. And then all the green marks are the same person putting in lots and lots of orders. So, and every time the order becomes every time the order becomes a new low price, the best offer goes down. So you can see that the price that you're supposed to get, the best execution keeps going down and down and down and down. And then right there at the end, oh, it's not being very nice today. Okay, whatever. Right there at the end, right here, Mr. Sell says, well, obviously something's actually happening. I better I don't want to lose all my money, so I better start selling. And then our manipulator actually puts in a giant buy order to meet them, and they've just, since this is a rather large spread, they just netted a nice 9-cent per share profit. And the best thing is they can just turn around and do the exact same thing, only push up the buy price. And, you know, you make 9 cents a share. That doesn't sound like much, but you can do it in a few seconds. And I've calculated the hourly rate of some of the actual instances of this, and you make a nice hourly rate. Like I would like.
Some firms are doing it like a million times.
Yeah. Because remember, you can automate this. Like people trade with
That's the other part,
computers.
is now it has to be, you can't trick someone manually typing that quick. This all happens over a few seconds. You're
Yeah.
basically trying to gain somebody else's algorithm.
Mm-hmm.
So that you say, oh, it's tanking, but we don't know why. We better
Yeah.
sell.
Yeah, and so actually some of the things we catch are actually referred to us by, other, FINRA gets referred to by other high frequency traders going, someone's screwing with my algorithm. We're losing money. Fix this. Yeah, and so again, not gonna make any grand conclusions here, but just as long as I wanted to look at realistic stock market data, why not look at the only symbol anyone really cares about? So this is what you get from IEX. They just give you a giant hex dump, so that's cool. Fortunately, there's a super cool person on the internet who created a parser who will turn it into a JSON file. Thank you, guy on the internet. And so then it turns into this, which is still kind of a morass of babble, but you can work with it. And so just you ask, how can I read JSON? You just use the read JSON function. And if it's not super nested, you can just do it like this. If you do have a very nested JSON with very, very heterogeneous schema in all of the various nestings, there is enough flexibility. You can kind of program in the schema so it'll do it right. But yeah, if you just have a nice little thing where there's a list of unnested dictionaries, you can just feed it to read JSON and set it to records, and it'll do it right. And here, to answer, you can use the isNA method to find out if something is NA. So there's a bunch of types of data I didn't really want to look at here. So you'll see that there's a bunch of columns that have all NA values and nothing else. So I can drop those. I can say drop NA along the column axis and only drop them if all of them are NA. And so I get rid of about 6 of my columns. And I see that the all NA columns are gone. I have these 2 that have a bunch of NAs, but there's a very good reason for that. It's because the trade ID only appears if there's a trade, and I have 2 different row types. I have a trade and I have a price level update. So that's updating someone who has put in an order, but it hasn't traded. And here's data types. So you'll see it figured out the data type of some of them, and some of them it called an object. So if I start trying to do anything to the objects, it might figure it out and it might treat it some way I don't want it to. So unfortunately, Pandas seems to be pretty bad at figuring out when things are strings. So you sometimes just have to tell it which columns are strings. And do not ask me why. For a lot of other data types, I would be able to just write int as the type, and it would work. String, you cannot write str and expect it to become a string. You have to do string in quotes to change it to a string type. I don't know, for reasons. And then just a few niceties. Also, I find that my second least favorite thing to do is deal with timestamps. Yeah. Yeah, I know. It's like they invented this thing when they were writing in cuneiform, and then about 10,000 years of telephone later, we have time reported like this. So yeah, time, I just want to change it to the Eastern time zone, Eastern Standard Time, because they're originally in UTC, and so that was super annoying. Then I just want to find the orders, and I'm going to kind of skip the things where I actually turn this into the price level updates into actual things that show up on a graph. So here I just want to calculate, like, if there's a new price level introduced, I want to carry it to the next row. And if in the next row they say, no, that order for 4545 is no longer there, I don't want to carry it to the next row. And if there's another price level update later for, $55 for 50 shares, I want to carry it to the next row. And okay, so the takeaway here is generally, if you use this, you're doing it wrong, but you can do this. So you can loop through your rows as you can turn your rows into a generator with this iter rows method. Again, generally speaking, if you do this, you're doing it wrong and it's going slower than it needs to.
Is that the reason why you think it's wrong? Because of the performance?
Yeah.
Okay.
Yeah, generally you want to do something that's a little more like vectorized in the num.
That's what NumPy is good at.
Yeah.
Vector math.
If you don't take the data frame itself, then it's really, really low.
Yeah. Yeah, and so I want to just go through here and and then I calculate a midpoint. Okay, and now this is the more old school Plotly. So I've got my data frame for a single day. I've got a timestamp. So for each trace I want to add, I put the two different series. So see daily, like my data frame, the column I want, then Y is data frame and the column I want. And then we finally get a graph. And so this is Friday this is Friday before everything was super weird. I think this is about where kind of the normal price and things kind of jumped. So these green line is people actually doing trades. So the green line is things that actually happen. The blue line and the red line are the best prices on IEX at any given time. When they suddenly jump down here, that's usually just because all the orders that anyone would actually want to buy at are out, have been sold out, and everyone's probably buying on a different exchange while these prices come back. Let's see, and I found that putting all the price levels was just too many points. And so this is kind of the value weighted average price of the offers. And can I get the bids? But yeah, so you can see by the average of the quotes, everything's way down here. So everyone's basically saying, yeah, I will buy this for a very low price. I will buy this for lower than what it's trading at. And then you can see the behavior really shifts by Monday. So you have this, the average price of the quotes is way above what everyone's actually trading at. So there's a bunch of people who are going like, I can sell this for a lot of money. I think a few days from here, I found the highest sell order someone put in was maybe 14 grand a share. So it doesn't cost you really anything to like put in a ridiculous order. It's just no one's gonna take it.
Do you think they put that in to screw with the algorithms?
It's possible. It's always possible, but that ridiculous, like the algorithms almost certainly have a filter for that. Like I mean, I don't know how they work, but I would put in a super basic filter like, hey man, like, yeah, throw out the outliers. But yeah, and then you can, very important moment in the whole thing. Interesting thing that he actually tweeted that in after hours trading. So you can see where all the activity kind of settles down and then, gets another bump. Which, I don't know, might have been a smart move to avoid the SEC getting mad at him. But yeah, and then I think tomorrow is when it hits the high price. But things are starting to just kind of get kind of nuts. And this is when the price gets almost 400 a share. And yeah, but you can also see that the value of the quotes is actually sort of tracking the trades. So things seem like they're starting to get a little more reasonable. You have a bunch of people. The party's almost over right about here, but you've still got a bunch of people who are like hopeful that it's going to hit 400 again. It's totally going to happen. Oh. And then it does briefly happen again, but then things get down. And these are the true diamond hands right here. I don't want to make too much fun of people who got into this, but it's not often that stocks are exciting. So it is. Yeah, and like the fact, yeah, I mean, and it's just really hard to let go of the fact that it could be you. You could be the one. If you get in at just the right time, you could ride that irrational comet to the sun. And finally, a use for melts. I just want to turn my type into either the average of the quotes or the midpoint of the best prices. And I can use Plotly to just make two, make those facets, so automatically create a graph for each type. I'm not sure why. Okay, there it goes. It just took a minute. All right. But yeah, so this is just a graph of the average quotes. You can kind of see at the beginning of the week, the quote price and the trade price are kind of tracking with each other. Suddenly, the quote price is much higher than the trade price, and it goes on like that. And here, the quote price is getting more in line with the trade price, but it's also crazy. And here, just stuff is happening. So, this is not an official measure of volatility or anything, but I do think it actually tracks pretty well with if the quotes are not in line with the actual trades, things are no one really knows what's going on. There's some kind, no one actually knows how much a company is worth, but there's a certain wisdom of crowds that's going on if there's the trade price and the quote prices kind of average out. Whereas if just everything's all over the place, no one knows anything. And if you are playing with your 401k money, you should stop. Like immediately. Okay, and the midpoint is just nice because IEX prides itself on executing orders at the midpoint, and they deliver. So the trade prices do in fact happen pretty much on the midpoint. I will be contacting IEX about these points. Very disappointed. But you know, what can you do? It's a chaotic market out there. Well, thank you very much.
Just can I ask you a question?
Yeah.
So earlier you mentioned Pandas like starts to struggle when you have like 5 million data points.
Mm-hmm.
What tools do you bring to bear when you just have tons of data? Do you start to switch to a different tool? For the
Yeah,
or, like,
Spark.
Spark, okay.
Yeah,
Also
typically.
coming along now is Dask, which is built on Pandas. So it can do it.
Yeah, I've heard interesting things about Dask. I haven't had a chance to use it.
The only thing I don't like about it is it doesn't really have a SQL interface.
Okay.
Yeah.
But Dask you can run on your laptop, too. You don't have to have a cluster, it's different version. But it basically, it still uses Pandas, but if it can't fit in everything in memory, it breaks the Pandas up into mini Pandas and will split them out. So that you can, you know, do much larger data sets than you normally should do.
Yeah, but if you're trying to do big data frames locally, you should still have some beefy memory.
Any other questions for Chris?
Yeah, how many rows are you typically dealing with?
Yeah, when I was doing the FinRA stuff, like there are literally billions of transactions every day.
Right.
So and the best part is I think there are only hundreds of millions of trades every day, but people are just constantly order cancel, order cancel, order cancel, order cancel, order cancel.
Once every time they merge or route.
Yeah.
Lines.
Oh, good God, the routes. Like, yeah, they created a whole new reporting system called the Consolidated Audit Trail because, like, just orders just kept getting lost. And no one could find out where they came from. I mean,
It's also built to replace the old node system because the one thing is like in that layering,
Mhm.
you can see the firms that put those orders in the market. You don't see who.
yeah, you didn't see customer data.
So CAS can take it down to find it that it's you and not what you broke.
Though to make you feel better, you do just show up as a number. So I can't search for, you know, you specifically. I just know that this customer number is doing bad stuff.
What's the benefit of declaring the column type as string instead of leaving it as a number?
I just occasionally, I couldn't tell you exactly where it goes wrong, but I have run into cases where weird stuff has happened, and I've just traced it back to a type problem. And so it's usually everything just works fine. And I turned it into a string primarily just to show you guys that you could change the type of any column you want to, and just to be safe. Because then I always get worried when a column is an object type. Because I'm never 100% sure what will happen if I do something to it.
CSV, somebody actually puts a comma somewhere, so that you import it, one row's off.
Oh,
I think also it only reads, doesn't read the whole data set beside the columns here, so.
yeah, like.
So look at a sample, so it may not get it right based on that.
So if I heard you right, you're asking if will it mess everything up if you try to read a CSV and there's a comma off. Yeah, so I think what you're saying is that you can read it in block by block.
Well, it tries to guess what the column
Mhm.
is, so if you know, it's better to set it explicitly.
Yeah. Generally, I think I did read a CSV somewhere in here. Oh yeah, it's this one. And yeah, so it's like if I know where the header is, then I can bring, yeah, and you can choose your delimiter. But yeah, if there's a straight up mistake, it's gonna think there's some column there that isn't there.
What happens on like sum? Because if you try sum or you min max and it's got that straight in a numerical.
Oh yeah, it's yeah, I mean, and that's kind of why you do some inspection of the columns. Like if you have a numeric column that doesn't show up in your little describe function, then something happened there. If the D type show
Sparse columns too, it may not have enough data to even guess the type.
Mm-hmm.
So things like that. So it's just, I think they'll make it a number.
Yeah, but yeah, so it's one of those things where I don't think there's any foolproof way to read in. I think you have to actually just you have to do your job, unfortunately. And part of your job is to actually make sure that the data looks like it's supposed to look. You know, numbers are numbers, letters are letters, timestamps are timestamps in the proper time zone. To nanosecond, they report in nanosecond precision these days too. So like the person who gets their order in a nanosecond before someone else gets first dibs. Yeah, that's kind of the incentive for these high frequency traders. First one there wins.
That's why they pay big bucks to co-locate the equipment.
Yep.
Exchanges.
And that's why the exchanges enable them, because the exchanges make a lot of money off of getting HFTs to co-locate their equipment.
It's not like you do things that are illegal.
Yeah.
In the web world, there's a lot of like automated testing that's done to verify that the code works. I imagine that's a little different when you're working with data. Are there any tools that you as a data science use to like test your stuff and make sure that it's doing what you think it's
That is like when you get to the machine learning level, it gets much easier to test. But even there, it's kind of an evolving kind of methods, exactly what you need to test. But yeah, it's surprisingly difficult to write ironclad data quality checks, because you try to come up with, it's like other testing, except you just got to come up with a whole different type of way things can go wrong. But yeah, you're just like,
That's only good until you rewrite the data.
yeah. So there are checks, but it's kind of, I would say it's not super mature. Like the checks I see are more like, is this outside of 2 standard deviation, is the average of this column outside of 2 standard deviations of what it's usually been? Which is something. But, also it's just like, I think it's hard to get the person out of the equation when it's like, I always think of data as you're trying to map something that actually happened into a computer, and it's really hard to take the person out of that. Or at least I hope it is. Until I retire.
Yeah.
Then they can automate
The
it.
machines can take over. Any other questions for Chris?
This may not be something you can answer, but the outputs, the figures and stuff are good. Is there any way to get those, like pipe them into a web framework like Django or Flask?
Yeah, a Plotly is a JavaScript wrapper. Like the thing I use for Plotly is just wraps Java, the plotly.js. So it's pretty straight. Like, in fact, you can export it to straight HTML.
Okay.
So it's actually Plotly wants you to use these as web interfaces. And yeah, so Plotly is a super cool library, and if you want to do more dashboardy type stuff, there's a few button options in Plotly, but Dash
It's
is.
a lot more web friendly, because that's kind of what we're
Mhm.
for, is building web-based apps.
Yep. Yeah, so both of those are very straightforward to get onto a web page because that's what they want to do.
The big thing is that they're interactive, where
Yeah.
a lot like this is static.
Yeah, I mean, yeah, Plotly is, yeah, you can make more interactive graphs than what I had here. Yeah, but again, when you get to a few 100,000 points, you gotta start sampling them, or things get hairy.
Interactive tables. Are there any good solutions or anything you use to be able to interact with your table in the network?
Man, yeah, Excel. Are we still recording?
There's some new add-ons for Jupyter notebooks we use.
Yeah.
For those who are looking into, especially if you're using Jupyter.
Yeah, no, it's true, and you can make it display pretty much as many rows as you like. It's just hard to. It's hard to search through them. You just end up using the web, like your browser's find function, which feels like horrible.
But there are a lot of like PD read for CSV, there's one for read Excel,
Mhm.
you really have to.
Yeah, and
You can also use write them back out.
yeah, you probably encountered at FinRA a lot of like when we talked to more business, like the analysts who went to business school rather than the analysts who are kind of computer scientists. They really love Excel tables, so you always make sure you can export to an Excel table. Bonus points, yeah, bonus points if it's color coded.
Cool. Thank you, Chris.
No problem.